Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 49 from the Smith Organic Chemistry textbook. And this problem asks us to draw the products of 4 oxidative cleavage reactions. And so each of these reactions is going to feature ozone and then a workup. And in order to solve this problem, we just need to remember what the results of oxidative cleavage are going to be on alkenes and alkynes. So alkenes are going to be cleaved into ketones and aldehydes, and alkynes are going to be cleaved into carboxylic acids. So with that being said, I'm going to answer these questions now. My answers are going to be in green, and I'm actually going to put the answer to A underneath where I've written A, just because I don't want to cram it in between A and C here. So remember to solve these. It may help to think about just drawing a line through the double bond or the triple bond. And so when you do that, you see that this molecule will be split into acetone here and propaldehyde. So we'll also get CH2CH3. Right. Okay. So the other parts of this problem are going to follow that exact pattern. So in B we have another alkene. So this will be cleaved. So we can draw a line through the double bond, and then we just need to draw our 2 pieces. So once again, our left piece is going to end up as a ketone, and our right piece is going to end up also as a ketone. And once again, it's acetone, actually. Okay, so there we go. So then for C, and again, I'll put C underneath where I've written the problem. So we can draw a line through the alkyne, and then we just need to remember that since it is an alkyne this time, our products are going to be carboxylic acids. So there's our ring. So there's our ring. Here's our carboxylic acid. And I did misspeak there. So remember, a single carbon, so a terminal alkyne, such as we have here, is actually going to end up as a molecule of carbon dioxide. So we have a carboxylic acid and an equivalent of carbon dioxide here. For C, so for D, we have a symmetrical molecule. So we're actually going to end up with 2 equivalents of a carboxylic acid here. And remember, it is just going to be this one molecule just because it's a symmetrical molecule. It's symmetrical. Both sides of this alkyne are the same. And so we're just going to end up with 2 equivalents of this carboxylic acid here. And so that's the way to approach this problem. We just need to remember what ozone does to alkenes and to alkynes, and then draw the products. And again, I think it's helpful if this is something that you struggle with. Just draw a line through the double bond or the triple bond, draw what's on either side of it, and then fill in the terminal pieces. Again, that would be ketones or aldehydes for alkenes, and carboxylic acids for alkynes. And if it's a terminal alkyne, then it's a 1 carboxylic acid and 1 molecule of carbon dioxide. And that's the answer to Chapter 12, problem number 49.